Phase induction motors are very popular because of their simple, robust construction and high reliability. Let's understand the construction of induction motor. There are mainly two parts in an induction motor: stator and rotor. Stator. It is made up of number of stampings in which different slots are cut to receive three-phase winding, which is connected to three-phase AC supply. The three-phase windings are arranged in such a manner in the slots that they produce a rotating magnetic field after AC supply is given to them. Usually, windings are kept at different pitch circle. The windings are wound for a different number of poles depending upon the speed requirement, as speed is inversely proportional to the number of poles, given by the formula Ns is equals to 120 F upon P, where Ns is equals to the synchronous speed, F is equals to frequency, and P is equals to number of poles. Rotor. Rotor consists of cylindrical laminated core with parallel slot that carry conductor bars. Conductors are heavy copper or aluminum bars which fit in each slot. These conductors are braced to the short circuiting end ring. The slots are not exactly made parallel to the axis of the shaft but are slotted a little skewed for the following reason. Number 1. They reduce magnetic hum or noise. Number 2. They avoid stalling of motor. Working principle. When three-phase supply is given to the motor, the resulting current generates a magnetic flux phi. Due to the switching sequence of three-phase current in RYB, the generated flux rotates around the rotor conductor. According to the Faraday law, which states that an EMF induced in any closed circuit due to the rate of change of magnetic flux through the circuit. EMF is induced in the copper bar and due to this current flow in the rotor. The direction of current can be given by Lenz's law, which states that the direction of induced current will be in the opposite of the motion causing it. Here, the relative velocity between the rotating flux and static rotor conductor is the cause of current generation. Hence, the rotor will rotate in same direction to reduce the cause. That is, relative velocity, thus rotating the rotor of induction motor. Therefore, in this process, poles are induced on the surface of the rotor, and these poles always try to catch opposite poles which are rotating on the stator periphery. Thus, rotor rotates in the direction of rotating magnetic flux. Rotor poles always try to catch the rotating poles on the stator frame, but they cannot achieve the same speed, because if rotor is able to rotate at same speed, there will be no relative motion between the stator poles and rotor poles, and hence there is no change in flux experienced by the rotor, and in that case EMF induced on the rotor conductors will be zero. Therefore, rotor always rotate in less speed than the speed of the rotating flux. This process continues until the supply is given to the stator winding. So, in this way, induction motor works. We will discuss it in more detail in our upcoming videos. Hope now you have basic idea about how induction motor work. If you like the video, please like, share and subscribe. Thank you.